This is a quick little demonstration that shows that charges inside a magnetic field really do move in circular paths. We have here a power source that's going to supply juice to everything. We have a solenoid or a coil, which of course is a bunch of wire loops wrapped around a hollow core. And this little thing right here is the star of our show. Once it gets a current supplied to it, it's basically going to behave like a miniature little TV set. So let's give it some current. We'll turn on the power source. We'll dim the lights. And there's a top view of it. And yeah, what's basically happening here is electrons are being propelled from the inside of this thing to the outside. And where the electrons hit the little screen there, that really bright spot, and over here that really bright spot, that's where the electrons are hitting the little screen. And the electrons, they aren't in a magnetic field, so they are traveling in perfectly straight lines. And if you look at the edges of the regions where the electrons are hitting, there and there and there and there, if you look at those four edges, you'll notice those four edges, they are all perfectly straight lines. Okay, so now what we're going to take the solenoid, put it over top like so, and of course there's no current through the solenoid, so there's no magnetic field in the region just yet, so the electrons are still moving in straight lines. Now we're going to crank up the juice to the solenoid. We're going to supply the solenoid with a little bit of current. And yeah, you can see the edges of those regions, they're perfectly straight now because there's no current to the solenoid. As I crank up the current, you can see those edges, they become curved, they turn into circles. And it looks like my apparatus is dying a slow death. That was very well timed because we managed to finish the demonstration. Bye for now.